Hello, I'm Paul Beckwith, and of course, this is my famous sidekick, Shackleton. Shackleton the explorer. So, I've done a number of videos, as you've probably noticed, on the Arctic changes and blue ocean event, and when we can expect the Arctic to lose all of its sea ice. First in September and then in subsequent months surrounding September. And of course, when that happens, the Arctic will experience tremendous warming because there won't be sea ice up there to absorb the heat, to take up the heat. So instead of the heat going into latent heat processes to melt sea ice, producing the fresh water, producing water, melt water, the heat will go directly into the ocean instead. And since the sensible heat coefficients are much smaller than latent heat, then the Arctic ocean temperatures will warm greatly. And of course, that means that Greenland is isolated. Up there is the only cold spot. And as Greenland ice melt accelerates, how can it not when in a much warmer Arctic? Then we get the associated sea level rise. But also, the only cold spot up in the Arctic left will be Greenland, and the center of Greenland is at 73 degrees north latitude, which is offset from the North Pole by 17 degrees latitude. So you could argue, as I have in the past, that the center of cold switches from roughly near the North Pole, offset a little bit towards Greenland, to be centered over Greenland. So the new center of rotation of the jet streams, I would argue, will be that 73 degrees north region around the center of Greenland. And that will greatly change the behavior of the jet streams. So what I want to do is, in the next series of videos, I don't know how many, but I'm going to talk all about the jet streams, how they're changing, how they affect weather, how they affect weather extremes, and how climate change is causing changes in the jet streams, how the changing temperature distribution on the planet is changing the jet streams. And the jet streams exist because we have a cold Arctic and a warm equator. Air moves from hot areas to cold areas, so the air moves from the southern regions near the equator to the northern regions, and as this air is moving, you get a deflection to the right because of the Coriolis force, and this basically sets up and creates the jet streams. So the argument for a long time has been, and it's still valid, that as we get great warming in the Arctic gets warmer, it lowers the temperature gradient to the equator. Therefore, the jet streams have to slow down, and when the jet streams slow down, they become much wavier, and we get this phenomena called blocking, which I'll be talking about in detail. I've been researching up on all of the recent cutting-edge scientific papers on the jet streams and on blocking events, and I'm going to try to convey as much of that information to you as I can in this video and in subsequent videos. So let me get right started. Let me get started with from the literature. Ouch, cat! Just dug his claws into my shoulder. I guess can't blame him for that. Okay, so this is an article that I will start my jet stream discussions on, since it's a good overview. It just came out, so just Google jet stream is climate change causing more blocking weather events. It's by Carbon Brief. It came out June 12th, so just a few days ago. And I've put it out on my Facebook. So just find me, Paul Beckwith, on Facebook and subscribe. I've got a page, a personal page, and a group. and also on my Twitter at Paul H. Beckwith. I'll be tweeting out the videos and a lot of the original source papers that I'll be discussing when I talk about the changes of the jet stream. Of course, this is my YouTube channel. If you just Google YouTube, Paul Beckwith, you can find, all of my videos. And so I recently was talking lots about the Arctic, and most recently the effect of the coronavirus, industrial shutdowns, reducing aerosols, and how that affects the Arctic and the melt of sea ice, etc. And of course, this is my website, and this is the latest blog from a few days ago on aerosol reductions, the effects on Arctic temperatures, and what we expect in terms of the months surrounding September. Once we have a blue ocean event and we lose Arctic sea ice in September, how long will it take to affect the bracketing months? How long will it take for us to lose sea ice throughout the entire year? Okay, so there's lots of stuff there, and please considering donating and setting up a monthly donation to support my research and numerous videos. Now, of course, Earth Null School. If you Google Earth Null School and click on Earth in the bottom left corner and set it at the height to 250 millibar, that's about the height of the jet streams. And you can see the configuration of the jet streams. Okay, so they're ribbons of air. They're at the top of the lower atmosphere, the top of the troposphere, where the troposphere joins the stratosphere. The boundary is called the tropopause, so they're right there, and they circumvent the planet in both the northern and southern hemisphere. And because the Arctic is warming like crazy, the jet streams are slowing down and becoming much more wavy. There's also a seasonal dependence on them, and this is what we're seeing in the southern hemisphere, which is southern hemisphere winter at the moment. You can see that the jet streams seem to be much wider here. One of the things that happens because of the slowing down of the jet streams and they become wavier, they're also becoming wider, and because they're very convoluted, the area that they sweep, when there's blocking events, for example, a sharp ridge of the jet stream and it's stationary, it sits in one place, the area under the blocking is increasing with climate change. So the regions over which you're getting more extreme weather events is increasing. And I'll talk about all of the detailed scientific papers, but I want to give you a good overview in this video. So the question is, jet stream, is climate change causing more blocking weather events? We know the answer to that is yes, but the short answer is yes. The longer answer is there's a lot of different complications. So first of all, whenever there's extreme weather, look at what the jet streams are doing. The past few months have seen some crazy weather. So in the UK, for example, they've had the sunniest spring on record. But before that, they had the wettest month on record. So this is where I talk about weather whiplashing, going from one extreme state of wetness and rainfall to another extreme state of sunny, very, very hot, and drought. Now, of course, Siberia, what's going on in Siberia with their dramatic heat wave, persistent, long duration heat wave, a very strong, powerful ridge of the jet stream sticking and being stationary over Siberia, causing this huge heat wave with enormous temperature anomalies, temperatures of 30 degrees Celsius when it should be in the low, 12, 13, 14 degrees Celsius. And also, you'll recall that late last summer, there were lots of wildfires in Siberia. And then when they were covered with snow and winter came, we thought they were out, but many of them were still smoldering under the ground. And as it became warm up in Siberia, they broke the surface of the ground and They're termed zombie wildfires. So they're occurring already, which is a very unusual situation for Siberia at the moment. So the key to all this unseasonable weather is these persistent high pressure blocking weather systems. They can bring clear, dry conditions on the ground below for many days or weeks. They can become extremely persistent and last for weeks at a time. These blocking events, they bat away in oncoming low pressure systems that would bring the prospect of clouds and rain. So the jet streams are moving from west to east, and when there's a blocking, they can't go over the region of the blocking, so they have to move north or south of it, and therefore the weather that is being carried by these low pressure systems that are brought along by the jet stream miss a particular region. So that region is in a heat wave or drought, or in surrounding regions, that's where those low pressure systems go, so there can be consistent rainfall and floods in that region instead. So, boom or bust basically. But whenever you hear of a heat wave and drought in the summer, or bitterly cold conditions that last for a long time in the winter, that's basically going to be associated with one of these persistent high pressure blocking weather systems. And what are the prospects for blocking events in a warming climate? And how does the rapidly warming Arctic have a role to play in this? So this article looks at all of these different things, and I recommend you have a look at it. So first of all, what's blocking? Around the mid-latitudes of the northern hemisphere, low-pressure weather fronts bring cloudy, windy, and wet weather. They move from west to east. They're carried along by the jet stream, which is a current of fast-flowing air high up in the troposphere, the troposphere is the lowest layer of the Earth's atmosphere. So they encircle the mid-latitudes of both the northern and southern hemispheres, and they generally keep a steady stream of weather systems moving across the Earth's surface. So any low-pressure system or high-pressure system in between, they generally only linger or stay in one region for a matter of days before they're being shunted on by the next system. Okay, now this is a good article a good video by the Met Office on what is a jet stream. And who's this guy here? This is an even better video called Understanding Atmospheric Circulation Patterns. So make sure you definitely watch this video. This was of course me from a couple years ago in front of a blackboard drawing the Hadley cell and Ferrel cell and polar cell, and the direction of wind flow from Coriolis force, where you got high pressure and low pressure systems set up, explaining why the deserts of the world are where they are, explaining why we get west to east winds, etc., etc. So make sure you watch this video. But sometimes these weather systems, they get stuck in place for a long period of time, and this is what we talk about as blocking. So it's a generic term used often by meteorologists and climatologists, and it's sort of how a weather pattern is often gets set up. And there is a book by Professor Tim Wollings called Jet Streams, and I'll have to get that book. I don't have it. But blocking is a stationary and persistent weather pattern, most often an anticyclone, which is a high pressure system. Cyclone is low pressure, that blocks the oncoming jet stream and low pressure regions which carry storms. Now, with a high pressure weather system in the way, the oncoming weather is deflected away from it, goes above it or below it, or it stays stationary. So you can get extended periods of consistent weather, not just heat waves, but also in terms of unsettled weather. Under the high pressure region, the weather stays dry and settled for a few days or weeks. But if you're in the area where the weather fronts are and they get piled up, you're likely to get wet and windy weather for a long period of time. So you get these extremes. So the UK had its sunniest and fifth driest spring on record this year in 2020, and it had the wettest February just months earlier. This wet to dry shift is unprecedented. Okay, I'll continue in another video. Thank you for listening.